Our topic is 3 to 8 line decoder or binary to octal decoder. Now, this circuit is a combinational circuit in which we have binary code in the input and output is 8 line information D0 to D7. Now the truth table is drawn. In this truth table, the first column is minterm and the second, third and fourth column represent the binary code in the 3-bit. Then D0 to capital D7 are the outputs, and in the first row we have code of 0, so at the output we have 1 in the column of D0, but all other columns are in the 0 state. Similarly, another row in which we have binary code 1, and therefore the 1 in the column of D0 shifts 1 step and it becomes in the column of D1, and all other columns are in the 0 state. So in this way, the minterms are written because of the rules of minterm. If any variable has 0 state, it is represented by the complemented variable, and if it has 1 state, it is represented by the uncomplemented variable. Then we have the code of 2, and in this code we have XYZ variable 0, 1, 0, and we have 1 in the column of D2 and all other are 0. Similarly, at last we have code of 7, which is 1, 1, 1, and at the output we have 1 in the column of D7 and all other columns are 0. Now we can draw its logic diagram. We have 8 minterms, so we need 8 AND gates, and the inputs of the first AND gate will be X dash, Y dash, Z dash. The input of the second are X dash, Y dash, Z. Similarly, X dash, Y, Z dash are the inputs of the third AND gate, and in this way the last minterm is X, Y, Z, which are the inputs of the last AND gate. So the logic diagram becomes now we have different vertical lines. First line represents the variable X, then an inverter is connected with it, and output of this inverter gives us X dash. Similarly, another vertical line represents Y, and inverter is connected with it, so we will get at the output Y dash. Similarly, the line Z and inverter connected with it, and we will get the line Z dash. So the first AND gate has inputs X dash, Y dash, Z dash, and it gives the variable D0, so which is equal to X dash, Y dash, Z dash. Similarly, the second AND gate which has three inputs x dash, y dash, z, and the output gives D1. Similarly, we have other outputs D2, D3, D4, D5, D6, D7, and in this way all the 8 outputs are given.